In this video, I will go through how to get components and create a very simple relay circuit that will turn your 3D printer off automatically after every 3D print. Also keep watching because I have a bonus print, which is a case that we can put our circuit in that will keep us safe, and we'll put all that we have created in one nice little package.
The simple idea is that you break your wire that's going to your 3D printer. You're going to put a relay in between it, and that relay will be controlled by a Raspberry Pi that you already use for Octoprint, so that when you are done with your print, your Raspberry Pi, which is already using Octoprint, will send a voltage to this relay and disconnect physically this wire. When you want to turn your printer back on, then your Raspberry Pi will send a voltage to your relay to physically connect again and turn your printer on. Just to remind you how simple this is, I have 3 wires here that are male to female. One end is male and the other end is female. A small PCB relay and an NPN BJT transistor, and say AC cable right here. Because the relay requires 5 volts and the GPIO from our Raspberry Pi is 3.3 volts, we're going to use a simple NPN transistor, and when the 3.3 volts goes through the NPN transistor, it will transfer 5 volts into the relay. You will be using this with Octoprint, and we'll be going over a plugin that was made to be able to remotely turn your printer on and off. And right now on my 3D printer, I am printing a case for this that I'm gonna share in the description so that you don't have a 120 volt hazard just open like this. It's kind of scary. This would be a good time for a disclaimer to let you know that if you do not have experience working with high voltages, please do not try this at home. This does have the potential to kill you working with house wiring. The basic function of a relay is that you apply voltage from coil 1 to coil 2. That coil will cause a switch to occur here, which will connect this common port to either this port or this port. So normally, this port is connected to this port. It's called common to normally closed. When you apply voltage from C1 to C2, then all of a sudden this common port will now be connected to this port, which is normally open. So in summary, you're either connected from here to here, or when a voltage is applied, you're connected from here to here. So you get your standard AC cable. If you don't have one, then why the heck do you have a 3D printer? We got our black, which is hot, our white, which is neutral, and green, which is ground. We're gonna break the black, so you're gonna split that open. Then I will connect this guy to the common. And then I will connect this guy to the normally open. And next what we're gonna do is connect one male pin header to C1 right here, and the other male pin header that we have to C2, which is just the other side of that relay. And this will be the controlling signal for our relay. So first we're going to be going through the relay and through the relay to the collector of the transistor. The base of the NPN transistor will have another female header that will connect to the 3.3 volts on the Raspberry Pi, and the emitter side of the transistor will connect to the ground of your Raspberry Pi, so that will need a female header as well. So you should have 3 female headers in total. There's actually one more thing to do. Doing a simple connection test on your multimeter and making sure there's no shorts anywhere, because that could be very bad with 120 volts AC. So there we have it. We're gonna plug in ground, 5 volts, and 3.3 volts into the Raspberry Pi. So make sure you know which version of Raspberry Pi you have. Look at the pinout because that matters. Always make sure to plug in everything before you plug it into the wall. Do that thing last. I made a case for you guys. This case is a case that will allow you not to be shocked to death by AC. All right, so you print a bottom and a top, and you just put it in. That's what she said. All right, so you have one end of the AC cable going into a little slot here, the other end to a slot here, and then you have your Raspberry Pi connections coming out of this little hole. All right, honestly, like, forget about the stupid little bevels I put in to be able to put the case on. Just put it on as tight as you can like that. It's perfect. Go to the little toolbar here, Octoprint settings, holy ISO, and then you're gonna want to go to get your plugins, wherever the crap that is, plugin manager, and then you don't have one, so you want to say get more, and then you want to go PSU space control, and then it says please be sure to fully test like I told you. All right, and then we're going to go back into this Octoprint settings PSU control. For me, all right, so this is important. So on G code command M80, these are just standard on commands, is M80, and off command M81. And we are going to set up a GPIO switching method where we're going to use GPIO pin 2. M81 is on. M80. Boom. Just sent it. And obviously you have the blue light because it's connected to the Raspberry Pi is connected to the printer. However, you don't hear this loud rumbling, which means that AC current, that raw 120 volts AC, is not going to the printer. All right, so on Cura, we're gonna want to go to Preferences, Configure Cura, Printers, Machine Settings. Now you can see Start G code and End G code. And what did we say? M81 to turn on the printer. And then NG code. So similarly, so M81 at the start here. Similarly at the end, after you've done everything, then M80 space semicolon. Like that. And then close it. And that's it. So now every time you configure something in Cura, it's automatically, depending on your printer that you set it up for, it's automatically gonna put those G-code commands in, which in turn will trigger a GPIO pin on your Raspberry Pi, which goes through the transistor to the relay and turns your printer on or off. I hope you enjoyed that, and talk to you later.